bowels of the Earth, hundreds of thousands of tiny metronomes are keeping time. As ice ages pass, as droughts are broken, deep in the caves, the drops keep falling. The sculptures they create may hold the answers to many of the biggest questions in climate science. Even today, below my feet, the story of our rapidly changing climate is being recorded for all eternity.
So in most terrains, when rain falls, a lot of it just runs off into the river system. But in limestone and marble, because you have this extensive fracture network, a lot of the water is actually carried underground. And so water is a direct connection between the climate and what's happening down below.
And you couldn't see it more clearly here where the rock's being cut away like this.
It's beautifully illustrated here.
Isn't it fantastic? We're following the journey of water into the extraordinarily beautiful Wombeyan Caves in New South Wales.
So Paul, we've got a really nice example of a stalactite and a stalagmite. You can see the drips hanging off those stalactites. Well, those drip waters originated as rainfall on the surface.
Each drop contains dissolved calcite, released as it reaches the cave atmosphere, building these spectacular formations. Locked in are elements like carbon and oxygen from the world above. So you end up with a signature of the climate above in that stalagmite down below.
Exactly.
The caves here are close to the surface, and the drip rates Russell has measured are relatively fast. That means stalagmites here are packed with information on hydrological change stretching back hundreds of years.
We find over the last few centuries that conditions have come drier. There are multi-decadal to centennial scale variations in moisture, quite vivid ones.
But in other parts of the world, like Corkia in Italy, caves are deeper. And this is where paleoclimatologists get excited.
First of all, the cave is a huge cave. It's got something like 60 kilometres of passage extending over a kilometre of depth. And the Italian samples, they grow very slowly. The important thing about the site is that it receives most of its weather from the North Atlantic. And the North Atlantic is a crucial player in the global climate system. One particular core that we've taken is only 25 or so centimetres in length, and it goes back continuously for 1 million years.
A million-year climate record in 25 centimetres, extracted by a hand-operated drill. Compared to digging up other climate records, it seems extraordinarily simple.
Probably the richest paleoclimate information that we can get come from ice cores and marine cores. Now, the main problems with those records is that they're very difficult to date.
But with new dating techniques, it's now possible to establish the age of cave records from potentially the beginning of geological time, giving an absolute timescale to other climate records and providing complementary information from different regions. This particularly beautiful stalagmite comes from caves on the Nullarbor Plains, and it's taken hundreds of thousands of years to grow to this size. To get that length of time out of an ice core, it would need to be over 1 kilometre long. By looking at oxygen and carbon isotopes within speleothems, geochronologists can establish exactly when climates across the world change dramatically.
Because with the isotopes, they're a qualitative indicator. It tells us when things were relatively warm or relatively cold or relatively wet or relatively dry. We do see very distinctive events in that. So, for instance, the beginnings and particularly the ends of ice ages.
What forces the Earth in and out of ice ages is a hotly debated topic, and one which this team may help to resolve. In speleothems older than 800,000 years, glacial cycles are spaced at about 41,000 years, the same time interval between shifts in the Earth's axis.
So when the Earth is tilting more, you actually get a more extreme difference between summer and winter. And that tilt cycles backwards and forwards for about a 41,000 year interval period.
If that's the cause, what about the effects? Stitching together stalagmite records from climate regions around the world should give us clues as to how oceans and atmospheres respond to big events.
It's all additional information which allows us to build up a picture of how the Earth's climate and how the environments around the Earth have changed over time.
And that could be the key to understanding the big climate changes of the future.